Okay, let's talk about writing equations from a graph. This is fairly straightforward. All you have to do is find the slope on the graph, and you're going to identify M and B and just plug it in. So remember when we're writing equations, we're going to ask for everything to be in this y equals mx plus b, the slope-intercept form of the equation. This b is the y-intercept. So all we have to do is look at where the graph crosses this line. Okay, this one crosses at +2. We're going to find two nice clean points. This one looks good and this one looks good. To get from here, I go 1, 2, 3 down, so -3 over 2. So I have an M, it's going here, and I have a B, it's going here. I need a y and an x, because remember we're graphing linear equations always in two variables, and so I have y equals -3 over 2x plus 2. And that's the equation of the line. Let's double check it with Desmos. So I've plugged in the equation that we found into Desmos. I also included the y-intercept here and labeled it so that you could see it is in fact at 0, 2. And all we have to do is see if this matches the original graph we were given. And you can see here that it does. Let's try one more. So again, we're looking for, whoopsie. We're looking for y equals mx plus b. Let's find b first. We're going to go to the y-intercept. We're going to go to the y-axis, I should say, and look where the line that we're looking at crosses. This one is at -3. So b is equal to -3. And look at two nice clean points. To get from here to here, we go 1 up and 1, 2, 3 over. So our slope is 1 over 3. And I just want to remind you guys something real quick. I'm going to open Desmos, and that is about steepness. So I want you to look at what happens when the slope of the line is very big. Okay, this line is very steep. And I always think about, would I want to climb up this hill? Oh gosh, that would be really hard. What if that was, what if it was negative? Would I want to go down that hill? No, you're going to go tumbling all the way down like this. All right, so consider steepness. If this, when you're writing equations, if you have something that looks really steep like this, then you're going to have a whole number coefficient here for m on the x value. What if it is, let's go back to 1. So this is your quote unquote parent function. Actually, the parent function crosses through 0 equals 0. What if your slope is 1 over 3? Now we have this nice kind of gentle incline. And if it's negative, it's going to be a gentle incline, but it's going to be going down negative. So that's probably a hill that you would want to climb. So when you are faced with a picture like this, one question you might want to ask yourself is this really steep? Or is it kind of flat? And if it's kind of flat, then you're going to be looking for a fraction here. And we did find a fraction. We found, so we're going to substitute in this here, and this is going here. And the equation of this line is y equals 1 over 3x minus 3. Go back to Desmos, plug it in. Y equals +1 over 3. And then b was equal to -3. No, it was the other way around, wasn't it? Now I already can't remember. No, that was it. Okay. So does this match what we drew here? Does this, the graph that we found, that we wrote the equation of the line, match the picture we were given? And it does. All right, let's take a look at a couple that do not have nice, clean intercepts. And what I mean by that is when we look at this graph, we know immediately that this crosses right here at -3. It's nice and clean. When we look at this one, we know it crosses at +2. It's a nice clean intercept. What happens with a graph like this? All right, so if we are looking at this one, can we just select the intercept? Can we just say like, oh, I guess it's about, I don't know, somewhere between 0 and 1 and just substitute that in to y equals mx plus b? We can't do that. So we're always going to start, we're going to go from point slope to slope intercept, but everything needs to be in y equals mx plus b when we're done. So let's see how we do that. So we don't have a y-intercept, but we do have a point. And this point here is 2 over and 1 down, so that's 2, negative 1. And we can't use the graph to see what the slope is. So I have two nice clean points here. I go 1 down and 1, 2, 3, 4, 5 over. So we're looking at negative 1 over 5 for the slope. All right. I can plug that into point slope. So y minus y1, well, here's my y1 value right there, equals, anywhere I see m, I'm going to plug in negative 1 over 5 for the slope, times x minus x1, and x1 here is 2. Let me just write that down again in case you don't remember. We're going from point slope, which is y minus y1 equals m times x minus x1. Whoopsie. And we're going to take that and solve for y to get y equals mx plus b. So, solve for y. We're going to start by distributing. And then to solve for y, we still have this here added. So I see addition, I do subtraction. What I do on the left, I do on the right. This bothered a lot of people in class today. So if you're struggling with fractions, use Desmos. Or if you're good with fractions, you know that this is negative 5 over 5 is the same thing as negative 1. And you're left with, whoops, not plus, but minus 3 over 5. And you're going to plug that into Desmos and see if this matches. Now, there's a couple different ways you can check it. You can check it graphically, you can check it algebraically, you can plug this point in everywhere that you see y, you can use negative 1, and everywhere that you see x, you can use 2, and you can see if that's true. If you multiply that out and it adds up to negative 1, and actually it does, I can show you real quick. So is negative 1 equal to negative 1 over 5 times 2 minus 3 over 5, and it is, because this is negative 2 over 5 minus 3 over 5, and there's your negative 5 over 5 again, which is equal to negative 1. So algebraically it works. You can put it in Desmos and check the picture, and if you are struggling with this, don't forget to just put it in Desmos. So we're going to use Desmos to check. You can see here that I put the point slope form of the equation into Desmos. I've added the point to make sure that that is actually on the line. I can go back and make sure that it matches my picture that we were given. You can see here that it does. And then finally, you're going to want to put in the slope intercept form, and if it covers the original graph, then you've done it correctly. Okay? Last one, and I'm going to try and do this kind of quickly. So you have a point at 3 over and 4 up, 3 over and 4 up, and you have a slope of 1, 2, 3, 4, 5 over 1. So the equation, and you can see you can't, I mean, this is going to have a y-intercept somewhere, but you can't see it, right? So you're going to put it into point slope. Y minus 4 equals 5 times x minus 3. So again, and we're just going to solve for y, distribute, and isolate y. Y is equal to 5x minus 11. And in Desmos, this should match this, and the picture should look like this. Thanks for watching. I hope this was helpful.